Hi, my name's Harley, and I'm here to talk about my Eureka research program in the Game Theory Workshop. My research topic is on advertisement competition in Bertrand Duopoly. It's where you have a Bertrand competition, but advertising is also involved. Nowadays, you can see advertisements anywhere on the internet. However, I did not understand why a big company like Coca-Cola would also put that much money and effort into advertising, even though almost everyone knows what their product is. And I think that is very fascinating, and I soon realized that advertising plays a big role in the market. And today we'll be talking about how advertising affects the Bertrand competition. My research mainly consists of 4 papers, and they are Advertisement Competition in a Differentiated Mixed Duopoly, Bertrand versus Cornell, Cornell and Bertrand Competition when Advertising Rotates Demand, the case of Honda and Scion, Game Theory Models of Pricing, and Long-Run Strategic Advertising and Short-Run Bertrand Competition. This game consists of 3 stages, and the first stage is just the simple Bertrand competition. A Bertrand competition is where firms choose the price of the products and the demand is determined by the price, and they compete for the profit. In this case, the products are differentiated, meaning that they have the same function and quality, but they're not exactly substitutable. For example, some people may prefer one brand over another, so they would choose that firm even though the other firm might have a lower price. To keep things simple, we assume that there are only 2 firms, firm 1 and firm 2. As a result, the demand function is defined as Qi equals A minus B times Pi plus C times Pj, where I and J represents the firm 1 and firm 2. Pi represents the price for firm I, and Qi represents the demand for firm I. We let M be the cost to produce each unit of the product, so the payoff function is just the price minus the cost times the quantity. In order to maximize the payoffs, we take a derivative of pi I with respect to Pi because the firms are only deciding on the price. After setting the derivative to 0, we have the best response function for every single possibility of Pj. And solving the equation, we found the Nash equilibrium for the stage 1 Bertrand competition. Now, stage 2 of the game is when advertising is introduced. We define Zi as the advertisement level for firm I, but as the levels go higher, it requires more money to make a difference. So we have the price for advertising is K times Zi squared over 2. When advertising is introduced to the game, both firms have to choose their advertisement level as well as their price for the product. And the demand function is redefined once advertising is introduced. Similar to stage 1, we have the payoff function pi I equals to the price minus the cost all times the quantity, but also the price they spent on advertising. And after taking a derivative and working out the math, we also found the Nash equilibrium for the stage 2 game. The stage 3 is actually a little bit different than the first 2 stages because now the firms not only care about their own profit, they also try to maximize the customer utility or satisfaction rate. We define the utility function for each piece produced by firm I is Ui equals U0 minus Pi, where Ui is a standard satisfaction, but as the price gets higher, the customer utility drops. Because it is also a market with advertising involved, the demand function remains the same from stage 2. Therefore, we have the total customer utility function, U, equals U1Q1 plus U2Q2 minus the total cost of 2 firms minus the total price they spent on advertising. And after we work out the math the same way we did for the first 2 stages, we found the so-called Nash equilibrium. Because both firms are trying to maximize the utility, in this case, the result can be considered as best for the social welfare, so it's also called the social optimum. After solving all three games, we need to look at the results and analyze them. We let BE represents the simple Bertrand competition, and AD represents the Bertrand competition with advertising, and SO represent the social optimum. The first thing we're going to do is compare the different Nash equilibria. As we work out the math, like shown on the screen, we can see that the price in the simple Bertrand competition is greater than the price in the market with advertising, which is greater than the price for the social optimum. Also, advertising occurs more in a market with only private firms that only care about their own profit. The next thing we're going to look at is only the stage 2 game, or the market with advertising but private firms. We're going to be looking at how the Nash equilibria can change. After working out the math, we found that if the price becomes more important, the price for both firms are going to decrease. Similarly, if advertisement becomes more important, the advertisement level also decreases. And last thing, if the overall demand for the product increases, both price and advertisement level increase. And if the demand for the product decreases, the price and the advertisement level are going to decrease. These are my findings for my research. Thank you for listening.